Alright, we're going to be looking at some review questions for your test on descriptive statistics and the normal distribution. Number 1. The weights of 90 students in a school were recorded. You can see the table of data there. Part A, write down the mid-interval value for the interval going from 50 to 60. Alright, well, right in between 50 and 60 is 55. And so that's very simply the mid-interval value. Now I know some of you might be looking at this thinking, oh well, it can't actually go as far as 60. But think about this, weights in kilograms, these are continuous pieces of data. It is possible to have a weight of 59.9999999. So if you took the midpoint between 50 and 59.9999999, you'd basically end up with 55 anyway. This is very similar to the idea that with continuous data that we're looking at, say, in normal distributions later on, we know that the probability of x being less than something is the same thing as the probability of x being less than or equal. These are identical values. So when you're dealing with continuous data, you don't need to worry about the fact that it's a little bit less than, because it's basically the same thing thanks to the 0.99999. So for the mid-interval value, simply take the middle of the lower and upper bounds as given. Part B, use your graphic display calculator to find an estimate for the mean weight and the standard deviation. Alright, so let's go into Stat and we'll edit, and in List 1 we're going to put in all of our mid-interval values, 45, 55, 65, and 75, and then we're going to put in their respective frequencies in List 2, 7, 28, 35, and 20. And now then, we'll go to Stat again, but this time we'll go to the Calculate menu. We want to do one var stats. Your screen might look a little different at this point, but what's important is that your data is going to be the one in List 1, and then the frequency with which the data occurs, you've entered into another list, List 2. And so we'll find out that our mean is 62.6 when we round to 3 significant figures, and let's put in the units of kilograms, and the standard deviation, we know that we want to keep this bottom one, 8.86 kilograms, if I round to 3 significant figures. Alright, moving on to Part C. Find the weight that is 3 standard deviations below the mean. So we've got our mean, and we need to subtract 3 of the standard deviations. And so that's going to be 62.6, subtract 3 of our standard deviations, and that gives us, let's see, so we've got 62.6, and we're subtracting 3 of the 8.86. And that gives us an answer of 36.02. And of course we can always round this to 3 significant figures, 36.0 kilograms. Let's go on to question number 2. A random sample of 167 people who own mobile phones collected all of that data below. It's a slightly differently organized table, but once again we've got continuous data in some time intervals or class intervals, and then we've got the frequencies with which each of these different class intervals has occurred. So we have to start by stating the modal group. We know that modal, or the word mode, is the one that occurs the most frequently, and our highest frequency here is 41, and so we're looking for the actual group, and so our modal group isn't the highest frequency, it's the group that it refers to, and so that's going to be everything from 45 to 60. Part B, we need to use our graphic display calculator to calculate approximate values of the mean and standard deviation, much like the previous question. So we'll go to Stat, Edit. Now I would like to clear these lists so I can enter new ones. So I'll scroll up until List 2 is highlighted, and I'll press Clear and Enter. And same thing, I'll go up to List 1 and clear and enter. If you press delete, the lists will actually disappear completely. You'd have to reset your calculator with +712 in order to bring those back. Alright, so we need to put in our mid-interval values for List 1. So that's going to be 7.5 and 22.5, and 37.5, 52.5, 67.5, and 82.5. Those are all my mid-interval values. I need to use the mid-interval values whenever I'm trying to get an approximation for the mean or the standard deviation from a frequency table. List 2 will be all of my respective frequencies: 21, 32, 35, 41, 27, and 11. And I should just check to make sure I've entered the same number of values in both list 1 and list 2. Clearly I have. So I'm ready to quit and go back into stat, calculate, and again, one var stats, I need to tell the calculator that not only am I using the values inside list 1 as my data values, but I've also entered a second list called list 2 for all of their respective frequencies. We must say both of them, otherwise your calculator will simply find the average of the values in list 1 without taking into account their respective frequencies. And you can see that this time the mean is 42.4 if I round to 3 significant figures. 42.4, and we're dealing with minutes here, aren't we? So let's include our units. And our standard deviation is going to be 21.6 when I round to 3 significant figures. Now on a graph paper, we're supposed to draw a fully labeled histogram that represents this data. So I'm just going to have a look at my data here so I can use it as I draw my histogram. And I'll come over to, alright. And so I can see that I've got to have values that go from 0 all the way up to 90. I can't remember if the question specified that I should use a particular scale. It doesn't say so. So I've just got to go horizontally, everything from 0 out to 90. And so let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got about 18 squares across. So considering that I've got 6 different categories, I could make each square worth 5. Let me just move this over a bit so I've got room for my scale afterwards. Okay, so I could decide to set it up like 0 to 15, and then 15 to 30, 30 to 45, 45 to 60, 60 to 75, and 75 to 90. And these are going to be the times in minutes. And your vertical axis on a histogram is always frequency. And our frequencies, we can see, go as low as 11 and as high as 41. So let's make sure that we do get as high as 41. Let's see, I've got 13 squares here. So maybe if I went in increments of 4, perhaps 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and I'll just go up to 44, so that's going to be enough to include my highest frequency of 41. Now I have to draw my histogram. So I had 21, my frequency is 21 when I was in between 0 and 15, so we'll draw about a quarter of the way across here, and then straight down. And I don't have to leave any gap, because if it was a little bit less than 15, I would be inside this category, like 14.99, and if I was 15 itself, then I would have slipped into the next category. I can see that that one's at 32. And so because every single time will fit into one of these categories, these bars are going to be touching. And then generally, you'll find that histograms with continuous data, the bars will touch. Now we're up to 35. And now we're at 41. And lastly, 27 and 11. And 11. And that would be sufficient. If you really wanted, I suppose you could color in these bars, but that's not actually necessary. Okay? Let's move on to question number 3. state which of the following sets of data are discrete. Well, we know that speeds, we can have any possible speed, anything you can measure. We could have any possible number whatsoever if you had a device that was accurate enough to measure. So that one's not discrete. Numbers of members in families. Here we go. You can't have 2.74 number of people in a family, so this one is discrete. And the maximum daily temperatures? No, we measure temperature. We can have any decimal temperature whatsoever. Heights of people in a class measured to the nearest centimeter. Because we are rounding them to the nearest centimeter, a height of, say, 172.3 centimeters is no longer there. It's been rounded to 172. Or maybe it's been rounded up to 173, but there is a gap in between them because we've rounded to the nearest centimeter. And part 5, daily intake of protein. Well, I mean, protein is presumably something that you can measure. I don't know whether we're measuring in milliliters, milligrams, whatever the unit of measurement is. I'm sure that if we had a precise enough device, we could say have 42.74618 units of that protein, and so that will not be discrete. It is continuous. Now, we've got the box plot. For the statistics, for some data, we need to write down the value of the median. Well, the median, we know that it's this bar in the middle. This lines up with 10. The upper quartile, we can see, lines up with 12. And the lower quartile, we're not being asked for, but it does line up with 5. The minimum value present, we can see the end of the whisker lines up with 1. And we have to write down now 3 different integers whose mean is 10. Well, we know that if we had 3 different integers, let's call them a, b, and c, their mean would be found by adding them together and dividing by 3. And if their mean is going to be equal to 10, then we can just multiply both sides of this equation and find that the sum of our 3 numbers must be 30. Now there's lots of possibilities here. You just got to choose any 3 numbers that are different from one another that add up to 30. For example, you could have, say, 23, 4, and 3. That would be one set of 3 numbers. There is, in fact, tons and tons of different answers here. As long as your 3 numbers are different and add to 30, you have found a valid solution. Question number 4. The age at which a child first starts to walk is observed from a random group of children. We can see those 9 ages in months. First, we need to find their mean. Alright, let's clear these old lists from an old question. Clear, enter. And here, clear, enter. And now let's put in all of these values. We've got 14.3, 11.6, 12.2 and 14, 20.4, 13.4, 12.9, 11.7, and 13.1. And because I've only entered things into list 1 here, then when I do my 1var stats, calculate 1var stats, I can simply leave it as 1var stats and that's it. I don't need to tell it list 1 and list 2. It will always default to list 1. And because I don't have multiple frequencies for each of these data values, I don't need to refer to a list 2. So I can just press enter at this point. I'm going to just put in list 1, not that I have to, but just because I think it's good practice to remember that the first argument that goes into the 1var stats function is your data values themselves, and then you have the option of putting comma and a second list which represents the frequencies. Anyway, here we go. We can see that our mean, if we round to 3 significant figures, is 13.7 months. And the standard deviation is 2.52. Please round carefully to 3 significant figures. And then we need to find the median age. Well, okay, one way I could do this by putting all of the values in order. So 11.6, 11.7, 12.2, 12.9, 13.1, 13.4. What comes next? 14.0, 14.3, and lastly, our slightly developmentally delayed child, 20.4. and those are our 9 children listed in order. And of course we can just axe off the highest and lowest again and again until we eventually arrive at the median value of 13.1. Now you didn't actually need to put these numbers in order before starting, but you would probably get a method mark for doing so, so I highly recommend that you take the time to rewrite the numbers in order if it's a small number of numbers. But if you didn't want to bother because you wanted to risk being quicker, of course, you wouldn't get any credit if you had the wrong answer for not showing work, but you could do the same process just by working on the original values. We axe off the lowest and the highest. We axe off the remaining lowest and the remaining highest. We axe off the remaining lowest and the remaining highest, and so forth until we eventually land at our median of 13.1. Question number 5, we've got a stem and leaf plot that shows us the birth weights in kilograms of 27 babies. We need to calculate the mean birth weight. Alright, once more, it's going to be quickest if we enter this into the calculator, so let's clear this old list, and clear enter, and let's put in all of the values. Our key tells us that the stem of 1 followed by a leaf of 7 means 1.7. So let's put in our values then. 1.7, 1.8, 1.9. And now we've got a whole bunch of values. 2.1, a couple of 2.2s, 2.3, 2.5, 2.7, 2.8, and 2.9. I will do a count at the end to make sure that I've included all of my values. And in fact, I can see up here, it looks like I've got an error. So it's good to double check my values. It should be 2.3. There we go. Alright, let's go back down to the bottom and continue now with our stem of 3. 3.0, 3.1, 3.3, 3.4, a couple of 3.5s, a couple of 3.6s, a 3.7, a 3.9, and then I've got only 5 that start with a stem of 4, 4.1 a couple of times, 4.2, 4.3, and 4.7. Now I can see then that I've entered 27 values because my list is currently on the 28th value, waiting for me to enter a 28th value. That must mean I entered all 27. Wouldn't hurt for me to scroll up the list quickly to make sure I entered them correctly, but I think I'm okay, so I can quit, and now I can go Stat, Calculate, and I'll just do 1 var stats. I don't need to worry about a list 1 or list 2 because there is no list 2 of frequencies, so it defaults only to the list 1 values. And I can see that my mean is, if I round to 3 significant figures, would be 3. Alright, the 6 turns the 9 into a 10, 3.10. And these are in kilograms. Let's include units whenever possible. Now the median weight, well, our calculator has got this for us already. If I scroll down to look at the 5 value summary, our median then is 3.1. The upper quartile is Q3, that's 3.7. It tells us that the lower quartile is 2.3, and our calculator agrees with that. On the scale below, we need to draw a box and whisker diagram to represent the birth weights. Alright, well, according to the stem and leaf plot, 1.7 is my lowest birth weight, while 4.7 is my highest. So these are going to be the ends of my whiskers. Now let's put in the median of 3.1. We'll put in the lower quartile of 2.3. And we'll put in the upper quartile of 3.7. We'll draw a box around those values, and now extend our whiskers out to the min and the max, and there's your box and whisker plot. Please note that on a box and whisker diagram, we do not graph the mean anywhere. It's just a coincidence in this situation that the mean and the median are the same. Usually, the mean is completely irrelevant in a box and whisker diagram. That's only going to be the minimum, lower quartile, median, upper quartile, and the max.